And we're back. Hello, hello. So this is 16.2 number 1. Now, how does 16.2 number work? How does 16.2 number 1 work? So, you are standing, imagine you're there, hands in your pockets, and on the top of your head, you have an electron. You have an electron which has a charge, and on the bottom of your feet you have an electron. So the question is, what is the force of attraction between the electron on your feet and the electron, what's the force? It's actually not a force, they're both the same. It's actually a force of repulsion between the electron on your foot and the electron on the top of your head. How much force are they repelling each other with? Well, let's get started with doing some math here, okay? Because everybody loves some math. And people who don't love math, watch out for those people, okay? So, we're going to start out with our formula. Our formula for electric force is equal to Kc, the Coulomb's constant, times your first charge times your second charge over R squared. So that would be the electric force is equal to, now the Coulomb's constant is 8.99 times 10 to the 9th, but that only works in our universe. If you go to another universe, the formula still applies, but the constant is different. Remember that in traveling to parallel universes, okay? Now, the charge of an electron is negative 1.6 times 10 to the negative 19. And the other electron is exactly the same. Negative 1.6 times 10 to the negative 19. A lot of people just put one charge in. Big mistake. Now, the distance, the radius, is my height, which is 1.90 meters. That whole sum is squared. So, let's start mathesizing. F, the force electric, I'm going to leave this part alone for now. But let's take care of the part at the top. A negative times a negative is a positive. 1.6 times 1.6 is 2.56 times 10. You just simply add these. 10 to the negative 19 and 19 is 38. Down here, square this. And I get 1.9 times 1.9 is 3.61. All right, plug it through. Now, guys, most people get through this part no problem. Well, they do this all fine. They put in a calculator and the whole thing goes to hell. You don't actually need the calculator for that much. And the beauty of scientific notation is it makes everything so much easier calculation-wise. So just forget about 10 to this. Forget about 10 to that. 8.9 times 2.56 and then divide it by 3.61. You do that and you're going to end up with 6.375. Let's just make it 6.38. We only have 3 sig figs. But for scientific notation, it's simple. 9 minus 38. What is 9 minus 38? Negative 29. That is fairly simple. What happens is people, they got their numbers and they want to throw the whole thing into a calculator and you're doing all these pressing of buttons. It takes all this time and one little mistake, everything goes to hell and you can't really look back and try to figure out where the mistake is. Do as much as you can as a human. You're actually fairly reliable as a human. Now, by the way, this is a tiny number. It's only an electron. It's the smallest amount of charge possible. Well, it's not exactly smallest. So far, it's the smallest amount of charge possible. Expect a tiny thing. If you lose an electron, you don't feel any different, do you? Of course it's tiny. Now, everybody's electrons are the same, but not everybody's height's the same. I'm a pretty tall guy. If you're shorter than me, these guys are going to be a little closer, and their attractive or their repulsive force is going to be a little stronger. Just think about that. Not a lot stronger, but a little stronger. So just keep that in mind. Expect, if you're shorter than me, to have a slightly larger number.